Hello students, in this video we'll discuss the Dirichlet problem on the upper half space. Let's consider the Dirichlet problem on the upper half space. Here we are. That's the y-axis, that's the x-axis. And I want to find a solution, Laplacian of u is equal to 0, and I want u to be equal to f of x on the boundary, like that. I messed this up. Hello students, in this video we'll consider the Dirichlet problem on the upper half space. So we have the upper half space, we want to solve Laplacian u equals 0 on the upper half space, and I want u of x0 to be equal to f of x, some known function, right? That's the Dirichlet problem on the upper half space. Okay, excellent. And so what I'm going to do now is I'm going to map this problem onto the disk where I know what the Poisson integral formula is. So consider the mapping psi of z, which maps the upper half space onto the unit disk, right, by the Cayley transform. Psi of z is equal to z minus I, so I minus z, over I plus z, the Cayley transform. When I plug in, for example, any point on the real line. So for example, if I plug in 0, where do I go? Plug in 0 map to 1, right? So this is the Cayley transform, this is the right thing, okay? Excellent. So now what? So now we know that the function u of z, which is u capital of psi of z, is going to be what? This is going to map into the disk. I can express u by the Poisson integral formula, right? So this is going to be what? Is a harmonic function on the disk. Great, okay? We're called for a harmonic function, so if we're solving this problem, if we were to solve Laplacian u capital equals 0 on the unit disk, with u capital of e to the I theta being f of e to the I theta, just f of theta, like that, on the torus, then we know that u of x and y, u of z, can be written how? U of z is 1 over 2 pi, the integral, over what? Over the circle, so 0 to 2 pi. And I'll have a 1 minus mod z squared over a zeta minus z squared, and then I'll have a f of zeta d zeta. And this is the Poisson formula for the disk. Poisson integral formula for the disk. Okay, excellent. And so now what do I need to do? Now, where does f, so this f over here relates to that f, so let's change this, maybe let's change this a little bit, make it a little bit more clear. Let's turn that into a g, right? Let's turn that into a g, and we can turn this into a g over here. That's g, and that's g. Okay, excellent. And so now what I'm going to do is I can pre-compose this thing over here. So recall, what's the setup? Recall, if we want to solve Laplacian of u is equal to 0 on a domain omega, with u equals b on the boundary of omega, Then, and we have f mapping omega into a simpler region, psi, conformal, like our Cayley transform. This is conformal. Okay. Then if I solve this problem over here, Laplacian of u capital is equal to 0 in omega, in psi rather, and u is equal to what in the boundary? U is equal to b composed with f inverse. So that's the new boundary condition over here. So what we're going to do now is what's our boundary condition? So now I can update this information. This implies that u, which is going to be u capital composed with f, is going to be what? Is harmonic with the correct boundary conditions. Great. And so now what can we say? So now we can go over here and say what's our u of z? Our u of z, u capital of z, is going to be 1 over 2 pi, the integral from 0 to 2 pi of what? Of 1 minus mod z. Okay? Squared. And what do I do now? I have to replace this with psi of z. These are w's now, so this is in the w space. So let's do u of w. Okay? So since we're in the w space, to make it a little more clear, I don't want to confuse the z and w. So u capital of w will be 1 over 2 pi, the integral from 0 to 2 pi of 1 minus mod w squared over zeta minus mod w squared. Then what's the boundary condition over here? The boundary condition is going to be this f over here. It's going to be f of w inverse. So that's going to be a psi inverse of zeta. D zeta gives a representation for what? This is a representation for the function u. Now what do? I have to plug in what? What is w? W is equal to this psi of z. So now our u of z is going to be what? It's going to be 1 over 2 pi, the integral from 0 to 2 pi, and then 1 minus modulus psi of z squared over zeta minus psi of z squared, like this. And then f inverse of psi inverse of z zeta d zeta, right? And so now this expression over here, if we simplify this, so plugging in now, here's the long part of the calculation, you got to plug this into the formula to see what pops out, right? But the upshot is what pops out is going to be something like this. We're going to have u of x and y is going to be what? It's going to be 1 over pi times y, integral over r, when you change the variables, of 1 minus, then we're going to have an f of what? We're going to have an x minus what? X minus, we'll say s squared plus y squared, f of s ds over here. Beautiful. And so that's all I'm doing is I'm just plugging the formula. It's a good exercise to do, right? And so now this kernel over here, this 1 over pi y over x squared plus y squared is the Poisson kernel on the upper half space. And we will study this so this calculation is like very, very long and very laborious, but if you go through this calculation, this is exactly the expression you get. It turns into, you have to change the variables, of course, based on what this is doing to the disk. And this is, of course, mapping the disk onto the line. So it was, why did I go from the disk over here? So this over here is the unit circle. That's the unit circle. Okay. Where's the unit circle being mapped to by this function? The unit circle is being mapped to the what? This maps to the real line, right? So that's why the limits of integration are changing over here, right? So I just symmetrize this, right? And we get this formula, this beautiful formula for the Poisson kernel. And you can see it's very intimately related with the Cauchy distribution as well in probability theory. So there's a deep connection between this and the Cauchy distribution as well. So in further videos, we'll try to understand further the connection between the Poisson kernel on the disk, the Poisson kernel on the upper half space, and see if we can solve more of these Dirichlet problems via these integral representation methods. Thank you very much.